Hello, everybody. Welcome to our talk. Today, we're going to look at what we've done on Sysflow over the past year, specifically looking at this edge processing pipeline that we built that allows you to do real-time analytics on Sysflow data. This work was done with myself, Terrell Taylor, as well as Fred Arujo, who's around here somewhere.
Hello, Flickon friends.
He's going to come back in the talk to do a demo and look at things that we've been working on. This work was done at IBM Research, and let's get started. So first of all, we just have to do an acknowledgement. Part of this work was funded by DARPA research grant. This has been approved for public release and distribution unlimited. Okay, let's jump into Sysflow. And if you remember from last talk, Sysflow is really an open telemetry format designed for system monitoring. Specifically, it's designed to look at how a process interacts with its environment. How does it interact with the files on the system? How does it interact with the network? And how does it interact with other processes? The format actually takes system calls and lifts them up into behaviors. And when building this format or designing this format, we looked at existing technologies such as NetFlow. You'll recall that NetFlow actually takes network packet capture traffic, and summarizes that into sessions, which allows us to do scalable analytics on top of that. Likewise, Sysflow is designed to summarize system call information and into these similar flow-like objects to be able to do scalable analytics, generate policies, and the like. We really wanted to design Sysflow to be an open source format so that we can start standardizing telemetry and security in the cloud. The cloud has really done a good job of standardizing workflows and workloads, but we really see that security and telemetry have been very much fragmented. Okay, so now that we've talked a little bit about the format, we'll now look at a particular example of Sysflow to give you a better idea of what it is. So Sysflow is really a semantically compressed system events for scalable security, compliance, and performance analytics. We designed it with three things in mind. First was to be able to drastically reduce the amount of data that we had to generate over existing formats like audit and sysdig. Number two, we wanted to design a format that could be easily analyzed with big data platforms so that essentially it would really simplify that aspect. And number three, we wanted to be able to link particular records together so that we could do provenance, threat hunting, and really provide that context that is so important for security analytics and other types of analytics. So let's take a look at Sysflow in a little bit more detail. Sysflow is really based on three things. First, it's an object-relational format, which has a set of entities, things like processes, containers, and files. And then it also has records a set of actions on those entities. And there are two types of actions. First are events, which are basically single point in time actions that are important to record. So for example, here, say we have process 1822. It's been running and it's going to clone itself into process 1823. So that clone would actually be an event. From there, it does an exec, which would be another event. And then it starts interacting with a set of network and files. Now, instead of recording each network event, we actually can then summarize that information into what we call a network flow and just summarize the number of bytes and the number of operations that occurred in communication with, in this particular point, this endpoint that's on port 2345. Similarly, we can do this with files as well, where we can look at files that were written and really summarize or read and summarize the information about that particular read or write. And finally, looking at, again, another net flow in this example, all the way up to an event, which again is the exit event to show that the process has exited. And so this allows us to really create this linkages, as you can see in this picture, which can allow us to do that context and that provenance tracking that we talked about. So here's the architectural overview. It's very similar to what we showed last year, but you'll see that there's now a new blue box in the middle that is called the processor. So if we look at the left-hand side of the slide, we have a worker node with a set of containers that we're monitoring, and we monitor them through a passive tap through inside of the kernel. We can either do this through trace points or eDPF type kernel injection, and basically record the system calls, which are then passed up into the user space where we have a collector, which aggregates those into Sysflow. And then we can actually stream them directly into the processor. Now, the processor is an edge analytics pipeline, which basically means that you can define custom plugins and put them together to be able to do various different types of analytics or do exports or things like that. And these plugins allow you to do things like, for example, as seen in the diagram, we actually have a plugin that is a policy engine, which allows you to generate policies, to do alerts or to do filtering. We can also create custom plugins to do enrichment. So if we want to add detailed information to Sysflow that's not there, we can provide that. We can also provide particular plugins for doing responses or exporting data outside of the system. So if we see there going towards the top of the diagram, that we can have an exporter plugin to export in various formats, JSON, S3, any of those types of things, into a global processing pipeline where we can do different analytics across multiple machines and things like that, and then feed that into data processing support to be able to do queries, build dashboards, and like to really provide an end-to-end threat management, threat hunting type environment. And so this provides a very lightweight framework to be able to collect and process analytics, and provides that significant reduction in data over existing closed source and certain open source platforms. So now we'll go a little bit deeper into that Sysflow processor to talk about the Pluggable edge analytics pipeline, which essentially is again made up of different what we call plugins and drivers. So we can see on the far left of the chart that we have a driver, and so a driver is basically defined as essentially a data source. In this case, we've already provided inside the processor the Sysflow data source so that it can collect Sysflow from the collector, but you could create drivers for other various formats like application logs or anything like that. From there, we actually built the processor in Golang, which allows us to essentially utilize Golang's multi-threaded and channel capabilities to be able to set up these pipelines and pass data from one working thread to another. So from a producer into a consumer, and so on down the pipeline until we export that data out. And so we can define these particular channels. In this particular case, we have actually 3 plugins that we custom built that are available right now in the processor. One is a flattener. So the flattener actually takes the Sysflow objects and flattens them into more of a data table type representation, which can then be fed into the policy engine, which allows us, again, to generate alerts or to filter out data. And then that can be then passed off into the exporter. And the exporter can change a different format and can send it out to various different data collectors like rsyslog, Elk, or Kafka. And so this really gives us this ability, to be able to do a various number of different analytics, plug into a lot of different systems, and again, be able to do a lot of different things very freely and continuously add because it is pluggable. So just very quickly, we'll look at some of the interfaces that you can use inside of the processor. So we have here again the driver, and the driver essentially follows this particular interface, which allows us to essentially pass in configurations from a JSON file to register that plugin, and then to run to do that particular collection of data, whether it be from a Sysflow collector, which is streaming data in over a data socket, or to link into a log file, or even like a Sysflow file, and bring that data in and pass it out through to the next channel. We also have the processors, which are those individual plugins inside of the pipeline. They'll have to follow this particular interface, which allows us to really, the main method here is the process method, which is essentially a loop which allows us to process individual records that come in from a driver or from another processor, and we can do the analysis and then pass it on down the line. So this here just really shows the pipeline configuration. The key points here is that we've defined those processor objects from that last slide. So here we have this Sysflow reader, which actually does the flattening of the Sysflow objects as they come in from the driver. And we have essentially a set of what are Golang channels. We have an input channel, which is in this particular case a Sysflow channel. And then the flattener is going to flatten it and pass it out of this particular plugin through the Flattener channel. And the policy engine is then going to take the things that it receives from that Flattener channel. It's going to run the policies that are generated on it, and it's going to then pass it out on an event channel to the exporter, which is then going to export things in JSON, into this case, into syslog. But you can define various things. So we try to make this as flexible as possible and as extendable as possible. We're hoping to get sort of community interest and can build some really nice things on top of this. And so right now I'm going to pass it over to Fred, who's going to talk a little bit about the policy engine, and then he's going to do a nice demo on some of the interesting things that we've been working on with the processor, some of the interesting things that could be done.
Thanks, Daryl. So one of the main components of the processor is a policy engine that takes in a declarative policy language that allows you to specify rules to how to transform the Sysflow stream flowing through the pipeline. And last year we showed you an example of using a similar policy specification to implement an alerting system on top of Sysflow. And what we have done since then is to implement this policy engine that runs at the edge with this extended capability of performing enrichment over the Sysflow stream. So specifically, what you can do is using these tagging capabilities to add metadata to the Sysflow stream as it observes them when they are matched specific conditions, such as this one shown in the example. And what this allows us to do is to, for example, take the MITRE ATT&CK TTP matrix and encode those TTPs as behavior patterns that are matched against the Sysflow attributes and automatically annotate them into the Sysflow stream that is exported out of the Sysflow agent. So to understand a little bit better all the capabilities and the components that we have talked so far, let me walk you through a demonstration of the kind of analytics that we can implement with the Sysflow processor. And here I'm going to be showing this through a Jupyter notebook that makes things a little bit easier for me to illustrate. So to start with, let's look at an Apache web server, HTTPD web server, that is serving requests from different clients. And as you see here, the graph analytics component is able to interpret the Sysflow stream and construct those graphs that basically encode the relationships that naturally are captured by the Sysflow records. So for example, the process control flows as the web server accepts new connections, it spawns processes and serves them and transfers them to a CGI interpreter that basically generates the response that is sent back to the clients, and also encodes the relationships with the file system activities and also network activities that are encompassing the behavior of this web server. So as you can see, underlying this graph, you still have your Sysflow records. So essentially, it's just a representation that we build that allows us to more easily reason on top of those behaviors. And one interesting thing that we can show, for example, when we deploy, for example, a web server that is vulnerable against a specific attack. So in this configuration, this web server, this Apache web server, has been set up to be vulnerable to the shell shock attack, which essentially allows us to do remote control, remote code execution over this web server. In this specific scenario, we leverage this shell shock vulnerability to execute a specific payload that allows us to hijack the control flow of the program and also execute some arbitrary commands over that end system. And what we, like I mentioned before, with the policy engine, we are able to automatically add or match over specific TTPs that we're observing in the incoming data. So in here, in those shaded red nodes, what you can see are actually nodes that have been flagged as potentially malicious based on the MITRE ATT&CK matrix. And if I zoom in a little bit, what you can see here is basically a sequence of TTPs that we actually observed, from the abuse of the native API, the exact system call, to resulting in the hijack of the control flow of the program, all the way to performing account discovery tasks over that endpoint. And as you can see here in the highlighted records, those are specifically the records that have been tagged with those TTPs. So the first one is when the bash interpreter, the vulnerable bash interpreter, calls on to executing the cat command, which should not be executed in normal circumstances in this web server. And then the second line, you can see where the cat command actually is used to read the information from etc. its C password, which basically it's a common pattern for enumerating user accounts in a system. And essentially that's what has been done here as the ultimate goal of this attack. So this is cool because now you have this way of basically encoding those TTPs and then have the agent or the Sysflow processor automatically annotate those over the Sysflow stream. So essentially that's how these rules look like. For example, here we have a condition that specifies reusable predicates or over the Sysflow stream, and then those are automatically annotated over the telemetry that we were observing. Another interesting aspect of this new approach of doing analytics is to look at all the different dimensions that you have in a given, for example, endpoint. So here we have a cluster that runs Kubernetes, and this tree map basically illustrates all the different containers that are running in this cluster. And here you can see in the different colors, you have file activity, file system activity, network activity, also process activity. And specifically, in addition, apart from all the infrastructure containers of these Kubernetes clusters, you have two user workloads that are deployed here. One is the app container, and the other one is the Node.js container, which we're going to be talking a little bit about in the next example. But let's dive into the app container. So inside this app container, you can see, the different, there is a Java interpreter running, a Java compiler. You have different, processes that are running inside this container, and this is all derived directly from Sysflow data. And specifically, I see a wget that has been executed out of this container. So let's take a look at what wget is doing. And here you see the network flow for wget, and this wget is actually talking to ESPN, which is very weird to be coming from a container. So that gives you kind of a telltale sign that something weird in this container. Another thing that you can look here into the remove program, right, that has been executed, like the binary has been called. So let's take a look at the file events associated with this remove. And here again, you see that remove has actually removed a test.java that has been written to temp. Also has removed temp.scopy. And scopy, as you know, is a remote copying program that is often used to, move program files from a system to another. And that's also a good telltale sign that something odd has happened to this container. So that's, for example, things that you can use to predicate over and also emitting alerts or implementing some interesting cyber reasoning capabilities on top of Sysflow. It also gives you the opportunity to do threat hunting, right? So looking at the provenance chains and going back to the specific root cause of all attacks. So moving forward, remember that we had a Node.js container. So in fact, that Node.js container has been deployed with this vulnerability for the Express components for Node.js that allows users to completely take control over that Node.js application. And specifically here we have already, we know an IOC, like an indication of compromise for this vulnerability. We know that in this attack we are actually deploying a script called xfuel or xfuel.py. So let's pivot over xfuel.py and filter for all the net flows and file flows. And basically, essentially, that's what you get back from the Sysflow stream, right? So we have the process, the xfuel.py that has been executed, and all the file flows or file system operations, and also net work operations that this malicious binary or malicious script has executed. And one interesting thing that we can do is automating some of the analysis for the network communication. And what we observe here in this, just by pivoting over this node and plotting the network traffic in here, is that we could easily implement an algorithm to detect this beaconing pattern that we are observing here. So you see here that there is a periodic communication with the command and control that eventually results in the exfiltration of the data to an external endpoint. And more precisely, we can visualize those patterns of network communication. For example, here in green, you see the main flow that goes to the back-end storage of this Node.js container, which contains sensitive information that the attacker was interested in. And here in those flows here that you observe to 104, those are actually external IPs pointing to a fake Twitter account from where the attacker actually exfiltrated the data that was contained into the object store or that storage. So that also is a very interesting way of you to pivoting on the different aspects of Sysflow, right? Going from process to file system onto the network in a very natural manner. So that's very good as well for when you want to, implement some instance response and threat investigations on top of, initial alerts that you may obtain from the processor. So that's the demo. And going back here to the main presentation, we just wanted to conclude this by saying that Sysflow is an open source project. And we have added recently this processor component to the family of projects that this Sysflow project contains. And we would love you to actually build your new plugins for it to contribute to the project. So if you are interested, ping us on our Slack, on community Slack channel, or shoot us an email. We would love to have more people joining and contributing to this project. Today we have a growing set of APIs. We support Python APIs like I showed in Jupyter, but we also have native C++ APIs and also Golang, right? The process is implemented in Golang, so we are growing our support for Go. There are so many ways to actually deploy Sysflow, starting from Helm for Kubernetes, OpenShift operators that we have now supported as well for OpenShift environments, Docker, of course, and also Ansible deployments, which we are making available. So to conclude this presentation, I just wanted to give the pointer to the GitHub project and also to our Slack channel. So please make sure to join the Slack channel. We're trying to have it more interactive and making sure that people, we try to answer questions or any issues that you have as quick as we can. And I would like to thank the Plugable organizers to give us the opportunity and the floor here to talk about Sysflow. We're very enthusiastic about this project. We think that it can really be, a game changer for how we capture telemetry from from end hosts and how we actually perform threat hunting from incidents that we observe from those hosts. So thank you so much, and I'll see you next time.
And I'd like to welcome Fred and Terrell. Thank you for sharing your work. We got lots of great questions coming in, so we're going to get right to them. First one from Jim asking, does the policy engine support transformation roles as well as alerting roles?
Yes. Hi, Shane. Thanks for having us here. Yes, it does. In addition to alerting, you can use the policy engine to encode rules or policies to perform enrichment. And what enrichment entails is basically a transformation over the Sysflow records, the data structures that we stream out of the Sysflow agent. And it allows us, for example, to annotate information about TTPs, for example, that we recognize in the patterns, in the behaviors that we observe with Sysflow. So it allows you to do that, add new attributes and so on. So yes.
Terrell, anything to add there, or we can move on to the next?
No, yeah, I think he covered it. We also, because we support the Pluggable system, if you want to do actual data transforms, you can build plugins that can take that the data that comes out of the policy engine and transform it into a different data structure to be able to do what you want, and push it out in whatever sort of serialization formats you want on top of the protocol. So
great. Next, we got a question from Discord asking, can you use Sysflow data to compare reported host data with queries to the host initiated from a central location to investigate discrepancies that might be indicators of a malicious process trying to hide its tracks on a host? And let me know if you need anything repeated there.
No, absolutely. So we designed Sysflow to basically be a recording of what's going on the host and in the containers. And this material can be used. It can be stored. So if you want to be able to do queries on historical information, but it can also be tied to other data sources. So for example, if you have a system that can then query it, so something like, for example, OS query, that you want to be able to see in snapshots, what the process systems look like, you can take that information and then look into your Sysflow data stream to see whether those match up. And you can also incorporate other data sources, like things like DNS, logs, and any of those things to be able to do that. So yeah, that's exactly one of the main reasons why we designed Sysflow and designed it in the way that we did. So.
Terrific. Next up, we got, how is Sysflow different from OS query?
So OS query, if you think of OS query, it's very much like a pull model. So you're actively pulling information from the host, and you can do that at intervals. So that kind of goes back to that last question of, if you have something at central, you may use OS query to actually query that information. So you get snapshots in time. What Sysflow really is it's a live recording of everything that's happening. So this process has been created. This process is talking to this host. This process is reading this file. This process is writing this file, and so we record everything that's occurring over that time period. So where something like OS query might miss because it's accessing things at intervals and doing queries at particular intervals, it may miss what's happening in those gaps. We can fill in all those gaps, but we can also use OS query as sort of like an enrichment tool upon Sysflow, so that you can have that stream of data that's coming in from Sysflow, and use that data that you get from it to query other things about the system. What's a DNS, or what containers are there, and things like that. So you can do.
So they can be used in conjunction with one another.
Yes.
Okay. Terrific. All right. So we got two more questions in the queue. So if you have any questions for Fred and Terrell, please get them in the Zoom chat now, or add them to Discord. But we'll move on to the next one. Fred, we'll address this one to you, unless it's for Terrell and you can pass it on to him, but we'll start with you on this one. What types of tactics, techniques, and procedures can you observe and automatically tag with Sysflow? And how are these enrichment policies defined and maintained?
Right. Yeah, that's a good question. So, well, first, like I mentioned before, to the first question, you can basically use a declarative specification language that the processor accepts, Sysflow accepts, that allows you to define those patterns. And those patterns, they can be predicated over, the Sysflow attributes. And the nice thing is that they are stateful. So you can go up and down the process chain. So you can talk about things, an application launching another application and so on. And the type of TTPs, right, that we encode today with the policy engine are related to the MITRE ATT&CK matrix. So we took the MITRE ATT&CK for Linux systems, and we look at all the different tactics, right, from the persistence, account discovery, and all those things, all the way to lateral movement and privilege escalation. And we try to enumerate them and encode those patterns inside this policy that is maintained as a YAML file, or a set of YAML files that are basically supplied to the Sysflow agent. And this flow agent is able to parse, interpret those, and then apply those as it sees the Sysflow string collected from the endpoint. And then metadata from the MITRE technique IDs are attached to the Sysflow records. And as you notice in the demonstration that we showed, we have these APIs or, friendly APIs based on Python that allows you to ingest the Sysflow data, transform them into data frames, and then use like the MITRE taxi server to get additional metadata for MITRE, and then even expand the context around those MITRE techniques, right? So you can actually get all the metadata all the way to leading to, doing some analytics on top with mitigations and all those things. So.
Great. Thank you for that answer. Just a couple programming notes before we move on to the next questions in case anybody missed the welcome today. Just a reminder, FlowCon has two events right now, looking for potential free registrations to next year's FlowCon. And those events we're looking for the person with the most FlowCon swag and the person with the oldest FlowCon swag. So you can add those to Twitter using the hashtag FlowCon21. You can add your pictures to Discord as well. And those winners will be announced tomorrow. Also, Josh mentioned in the welcome this morning, the Secure Code tournament starts today at 11:30. So I know there was a post to Discord talking about instructions for that and how to play. So make sure you check out that post to get up to date and get ready to start with that. So we'll move on to the next question. And that is, have you used Sysflow data to establish baseline models for host usage to proactively identify when a different user is on a host or a type of host use context that has changed?
Yeah, I'd like to take that one. We have actually deployed Sysflow in large cloud environments, in large clusters with internal applications in IBM, and we were able to find a few interesting instances where we identified, for example, users logging into those containers that they were not supposed to be there. We were able to identify misuse of certain applications and applications left behind inside containers that weren't even supposed to be there. And we could track this all the way to the user IDs and back to the potential origin of the interaction with those containers via the network patterns that Sysflow also capture. So yeah, in a nutshell, yes, we have done a few visualizations on top that also allows you to very easily pinpoint based on this graph-like abstraction that Sysflow generates which users are interacting with different applications running in containers or host systems.
Terrific. Thank you for that. Next one. Have you found any resource demand differences from one API to another that affects what might scale better for large networks?
I'm not sure exactly what.
I think we could talk about the differences we observe, for example, different benchmarks we did, the databases versus.
So I think probably what I'll frame this as is sort of being using the various different entities and flows and how they vary based on the workload. So we do find that that the amount of data generated depends highly on the various workloads in the network. So we found, like, for example, that things like a database, we actually get really small footprints because of the way that databases, reuse their connections, they reuse their files and things like that. So we get really good compression there. And then for some others that we get less compression. So for example, like a very stressed web server where you essentially have, a connection open, a file read for an HTML file, and then a close, you're going to get less compression on that. We still get several orders of magnitude over system calls and things like that. But yes, depending on the workload, you're going to see varying.
And maybe comment a little bit on the facilities we added recently to drop certain system calls and mitigate these issues. I think that's a good.
Yeah. We've been experimenting, with various things around the graphs, but also within the collector, to be able to reduce the amount. So we're looking at things like some of the heavier things that occur in a system are actually file reads, and so we're looking at ways to how to reduce those file reads for specific applications that are repeatedly hitting the same file over and over again. Some of this information is very noisy and not useful. So this is where we look at things. If we bring this back to NetFlow, we can look at like sampling things, sampling, but we can actually do more targeted sampling because we have more context. We know what the process is. We know a little bit more about what files being read and things like that. So we can start incorporating some of those things that you see in NetFlow collectors inside of the Sysflow collector to be able to improve that kind of stuff.
So before we get on to our next question, just wanted to give you guys a quick plug tomorrow. I know tomorrow you guys will be doing a demo session during the Discord availability. Anything you're going to want to plug there, or what people can expect that will attend that session or find you on Discord tomorrow?
Yeah, I think what we could probably do tomorrow to get people a little bit like a deep dive of what it's available, and it's open source, by the way, so you can actually experiment with it. I think we're going to do a deep dive on our Jupyter environment, maybe how to get the Sysflow data into that Jupyter environment, and then show some of the new APIs, the new capabilities we have. We could also tag team with Will, who is going to do the next presentation. He has actually built a pipeline on top of the Sysflow processor, which is the newest component of the Sysflow stack, to implement a reference monitor on top of it. So maybe that's another thing that we could potentially show.
Yeah, that would be terrific. Great. So make sure you guys look for that when you're on the demo tomorrow on Discord. Let's get on to the next question for Fred and Terrell. And this is, can this enrichment feature be used to automate recommendations for potential security remediations?
Cool. So I think you're referring to the enrichment feature of the policy engine. And yes, one thing that we have done in that direction is to correlate the different TTPs that we annotate, that we bind at the source with the monitoring mitigation framework. So we can use the technique IDs to automatically do correlations to monitoring mitigations and then use those as recommendations for threat analysts, for when we send that to the SIEM systems and so on. So that's one area that we have actually been actively working on.
Okay, we got about just about a minute left to you guys, so I'm just going to throw one at you. This is my first FlowCon. Have you guys been to FlowCon before? And if not, or if you have in person, your thoughts on the virtual experience so far?
So I actually was at FlowCon way back in like 2007. Okay. I think I went to a couple of them around that time period and did some presentations. I've always... in terms of virtual conferences this year that I've been to, I think FlowCon that you guys have done, and this goes to everybody behind the scenes, that everybody's not seeing, are doing an amazing job. Like I say, I was saying earlier that it feels like I'm going on Access Hollywood for joining this. So I think in terms of virtual experiences, it really created a great community around this. It's not the same as, I think, being able to sit in a room with the other people that you meet at FlowCon, made so many really good relationships from that. But in terms of virtual, it's one of the better ones that I've seen.
Yeah, that's my second one. I was there last year, and I concur. A second terror and everything. And yeah, I love the people in this conference and how technically grounded the talks are as well. So yeah.
Yeah, we appreciate the kind words. That was not a setup question. They got that one just sent to them in real time. But the presenters make it, so we appreciate everybody's flexibility with presentations and the adjustments and the whole community in general. We thank you for this new experience and making it a great event so far. So Fred, Terrell, thank you for your expertise. We appreciate you being here. We look forward to your demo tomorrow, and we're going to let you guys go.